C and, no, using P for something else. C and H. Thank you. That was sloppy on my part. All right, so we have one equation, two unknowns. Obviously, mathematically, that cannot be solved. We need another equation. Unfortunately, we have one. Because it's perfectly elastic, kinetic energy is conserved. And so, what's the formula for kinetic energy?
1/2 mv squared.
That was lesser than the last time. So I got 1/2 times 4 times 6 squared plus 1/2 times 10 times 1 squared equals 1/2 times 4 times c squared plus 1/2 times 10 times h squared. Remember that kinetic energy is a scalar. The direction of the velocity here is irrelevant because the formula would have mv squared. The v is speed, so it's 1 squared. Now, if you put in -1 squared, you get the exact same thing. Or you should. That's supposed to be a 0. So we now have, doing the fancy math here, this is 72. That is 5. Did that right? Let's see, that's 36 times 2, and that is 5. All right. So my second equation is 77 equals 2c squared plus 5h squared. Two equations, two unknowns. Questions to there? All right. So, how do you solve it? I got 14 is equal to 4c plus 10h. And I've got 77 is equal to 2c squared plus 5h squared.
Did you plug in the 6 and the 1?
For what?
C and H.
That 6 and the 1, or 6 and -1 is before the collision. This is after the collision.
You solve for C in terms of H or H in terms of C in the first equation.
Yep. All right. Which one do you want to do?
C is the one that's isolated.
All right, so we isolate C, so 4c is equal to 14 minus 10h. So C is equal to 14 fourths minus 10 fourths h, which is 3.5 minus 2.5 h. Look at that, do the second one, so I got 77 is equal to 2 times 3.5 minus 2.5h squared plus 5h squared. So, squaring a binomial, this becomes 3.5 squared minus 2 times 3.5 times 2.5 h plus 2.5 h squared plus 5h squared. 77 equal to 3.5 squared.
12.25.
There you get
12.25.
the 12.25 minus
17.5.
h plus 6.25 h squared plus 5h squared. Distribute the two, so I got 77 is equal to, that becomes 24.5 minus 35h plus 12.5h squared plus 5h squared. I have a quadratic here, so we have to employ our techniques for solving quadratic equations by getting the form to use the quadratic formula. So I have 0 is equal to, I have 17.5 h squared minus 35h minus, subtracting 77 from both sides, that's 52.5. Yeah, good. Now, our technique at this point is it will either factor or we'll use quadratic formula. What technique? What do you want? I think solve it.
Quadratic formula.
Okay. H equals 35 plus or minus the square root of 35 squared minus 4 times 17.5 times 52.5 divided by 2 times the, what's in front, so divided by 35. And what do we get? There's 2 answers.
I'm getting square root of a negative.
Not, oh, that's negative 52.5 there.
You want the answer?
Yes. I guess make a note here that this whole thing right here equals 70. All right, so what are the 2 answers?
Negative, or just 3? And then negative 1.14.
Something's wrong there. So if you do 35 minus 70, you get negative 35 divided by
I
35.
did minus 75 instead. So
Ah, okay, that'll do it. All right. So we end up with 3 or negative 1. One of these is the correct answer, one of these is not. But let's go ahead and find the value of C for each of these cases. I know that there's my formula for C right there. So if H is equal to 3, C is equal to 3.5 minus 2.5 times 3, which is negative 4. Or, if negative 1 is the answer, I get 3.5 minus 2.5 times negative 1, which is 6. tell you right now, we did something correct. Because one of those solutions I could have told you beforehand, without looking at the answers. So we have our choices here. Either after the collision, our two choices are the velocity of the 4 kilogram mass final is -4 meters per second, and the velocity of the 10 final is 3 meters per second, or the velocity of the 4 final is 6 meters per second, and the velocity of the 10 final is -1 meter per second. Which of these is the correct answer? And then why?
The first two,
Why?
because in the second two, they go through each other.
Or haven't collided at all? The advantage of this technique is that one of the solutions should be they've never actually hit, or they pass through each other. Which I guess is the same thing. They don't actually hit each other. One of the solutions should be what we started with. Because again, mathematically, we're trying to find something with the exact same energy, kinetic energy, and the exact same momentum. Well, that's the initial situation. So that is the answer. The disadvantage of this technique is there's a lot more math than the other two techniques. Questions on this before we hit the other another technique? I'm going to erase this, but keep that in mind. That and all right. Same setup. I got a 4 kilogram mass heading to the right at 6 meters per second. I got a 10 kilogram mass heading to the left at 1 meter per second. So the first thing I'm going to do here is actually solve it without the numbers. So I have M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. That's just conservation of momentum. We're doing mass times velocity. I'm going to shorthand this, make this A, B, C, and H. Just because I don't like writing all the subscripts. So I'll have M1A plus M2B equals M1C plus M2H. Now in our particular problem, A is 6, B is -1, M1 is 4, M2 is 10, but we'll keep it generic for the moment. I also know kinetic energy is conserved, so I get 1/2 M1A squared plus 1/2 M2B squared. It's got to be equal to 1/2 M1C squared plus 1/2 M2H squared. Kinetic energy formula with my total beforehand is total afterwards. Let's manipulate this sum. I got 1/2 in every equation, so I can just multiply everything by 2, get rid of it. I'm going to get the M1s together and the M2s together. So I got M1 A squared minus C squared. Bring this over. Let's put in the intermediate step. M1A squared minus M1C squared. And that's going to be equal to, taking that over, M2H squared minus M2B squared. So it's just got the M1 terms on one side, the M2 terms on the other. Factor M1 out, as I hinted a moment ago. Let's factor again. I got the difference of squares. How does this factor?
A plus C times A minus C.
A plus C, A minus C. And that's gonna be equal to M2, H plus B, H minus B. This is still just conservation of kinetic energy. Now what I'm gonna do is to simplify this is I'm gonna divide by what I have up here. I'm gonna manipulate this just a little bit, and we'll go for the typical stunning visual effects. Ooh. I'm gonna get the M1s together, so I got M1A minus M1C, and that's gonna be equal to M2H minus M2B. Factor the M1 out. So those two are equal to each other based on conservation of momentum. Now I can divide by this. I'm going to divide the left side of that equation by this, and the right side by that. As long as my denominators are equal, the math people say I can do it. M1s cancel, A minus C cancels, M2 cancels, H minus B cancels. What I'm left with by combining these two equations is A plus C is equal to H plus B, or A minus B is equal to H minus C, or V1 initial minus V2 initial is equal to V2 final minus V1 final. This is known as the speed of approach, the relative speed of approach. And this is the relative speed of recession. What that means is, if we are here, and we're trying to figure out how fast is this coming towards this. So from 10's point of view, it is coming at it at 7 meters per second. 6 minus -1. After the collision, from his point of view, how fast is he going away from it? Well, we had -4 and 3, so it would be 3 minus -4, which is also 7. What this gives us is basically we have, I want to keep that, let's get rid of some of this stuff. We're bypassing the quadratic formula. So solving the exact same problem, we have 14 is equal to 4c plus 10h. That still holds, still have to use that. We still have two unknowns, two equations. And then over here, based on that, we have 6 minus -1 is equal to h minus c. Which is 7. So h is equal to c plus 7. Plug that into here. I have 14 is equal to 4c plus 10, c plus 7. 14 equals 4c plus 10c plus 7. Plus 70. Subtract 70 from both sides. I get -56 is equal to 14c. C is equal to -3. -4 meters per second, which is what we have right here. I know that h is c plus 7, so just add 7 to that, we get this. We get the exact same answer. Questions?
If we were to use this method, would we have to do all that over there, or can
No.
we just use the?
So you can just come
relative
straight
speed?
to relative speed of approach equals relative speed of recession.
So were you just deriving it?
Yeah. I just, as you might have noticed, I had issues with the, hey, here's the formula. Assume it's true. Now, what happened to the other solution though? We started with the exact same two equations, but somehow this disappeared. Where did this go? At what point did it disappear from the answer?
Is it when you cancel it out, like the A minus B or something like that?
Yeah. Because the math people hate it when you divide by 0 because they haven't figured out how to do it yet. So they tell you you can't do it. The solution that's eliminated, A and C are the same thing. H and B are the same thing. So we're dividing by 0. That's the point where we got rid of that. We had the assumption that they are not equal. All right, so now, the third method, which is actually the method I prefer, but based upon previous classes, there's going to be at least one person for each technique. And then a couple people who will mix and match. Please don't.
I'm sorry, but it says relative speed of, I can't read the last.
Relative speed of approach equals relative speed of recession. All right, so this 4 kilogram mass is cruising that way at 6 meters per second. Suppose I, as the observer, am also going 6 meters per second that direction. How fast will this 4 kilogram mass appear to be? If I'm going the exact same velocity.
It wouldn't move at all.
So if the observer is going at 6 meters per second, this is going at 0. So it has its